Good morning, students. Okay, one second. Okay, very good morning. Today, let us continue yesterday's concept. Dear students, yesterday we have discussed this normal shift. Actually, this lateral shift and the normal shift are two consequences of your refraction. What is normal shift? Okay. Imagine we have some denser medium, water tank, or glass slab, whatever it may be. Let this be glass slab. An object is placed somewhere here. Object is placed somewhere here. Anyway, this is denser medium, right? Like right here, this is denser medium. Correct? A ray of light is allowed to form on the surface of this rectangular slabs. Let this be luminous object. What is the luminous object? Producing light. A ray of light incident normally will travel in second medium. A ray of light incident normally will travel in second medium without any deviation. Why? Why? Because this is a ray which is an incident along the normal. If ray is incident along the normal, we observe no deviation. There is no deviation produced. This is first. Let me consider one more ray. One second. Let me consider one more ray. Incident obliquely. Let this be normal. We know this ray is traveling from denser medium to rarer medium. This is rarer medium. Say air. This is water or glass, whatever it may be, some denser medium, transparent denser medium. When ray of light is incident from denser medium to at the interface, we observe it will the refracted ray will move away from the normal. The refracted ray will move away from the normal. Same here. Let me consider one more ray, say ray 3. This is third ray and a normal. We observe this ray will correct. When we observe normally like this, when we observe normally, let me trace it back. Somewhere here, somewhere here, somewhere here. We observe what? This object, which is actual position of object, seems to be raised up. ಇಲ್ಲಿಂದ ನೋಡಿದಾಗ ನೀವು ನೋಡಿದ್ರೆ ನಿಮ್ಗೆ ಹೆಂಗ್ ಕಾಣಿಸುತ್ತೆ? The object seems to be raised up. This phenomenon, when object is kept in one medium, say denser medium, and viewed from other medium, the apparent It is not real. It is not actual. It is apparent. Very clear. The apparent shift observed is called normal shift. What means normal shift? A normal shift is a phenomenon in which an object placed in some medium and observed from other medium, it seems to be raised up. There is a change in position of object. This virtual shift in the position of object is called normal shift. See, if I draw a line here, this will give you what? This is a real depth. Okay? This is an apparent depth. And this will give you what? Normal shift. Normal shift. We can explain for oblique incidence also. Oblique incidence will explain more. Okay, let me consider an object here. Like this be normal. I mean, a ray passing through the normal. See here. Let this be first ray and this is second ray. Okay? We know they will move like this. If you trace it back, the even matrix will form. Here too we observe what? There is some apparent shift in the position of object. In optics set of practicals, where in lab, where you are supposed to do, as I told earlier, 5 to 6 experiments, there is one experiment to find refractive index of a glass slab. What? To find refractive index of a glass slab. Where you have to use this concept, normal shift. Refractive index of glass is given by what? I mean, refractive index is given by real depth divided by apparent depth. This is a formula which connects refractive index of material with its real and apparent depth. This experiment you have to conduct in lab using spectrometer. Please remember, this is very much helpful there. This formula is also helpful in solving some of the problems also. Okay? Hope you understand. Okay. Now let us move to next concept. Without wasting time, let's move to next concept. Very important concept. The concept is called, let me write, very important, 3 marks. Okay. Name of the concept is total internal reflection. Name of the concept is total internal reflection. Shortly, it is called as TIR. TIR. TIR stands for what? Total internal reflection. This is very important. This may appear in exam for 3 marks. Write a note on total internal reflection. Write a note on TIR. What exactly is TIR? Without wasting time, let's start directly. Imagine we have some water tank filled with water. We have water tank filled with water. Some luminous object is placed somewhere here. Okay, point object, let's do better. Some object is placed here, point object. Now, when a beam of light or rays from this object are allowed to fall on this surface AB, which is refracting surface, what we observe? Remember, a ray which is inside normal at point A or B, whatever it may say P, will travel in second medium, which is rarer medium. This one is denser. Okay, let me write somewhere visible. This is denser medium. Don't think denser. This is a denser medium. Here we have arrow mark. This is denser medium. Let me repeat. When a ray of light is incident from denser medium on refracting surface along the normal, we observe there is no deviation produced, and hence ray will travel without any deviation in second medium. This is first ray. Let me consider one more ray, second ray. Okay. This is second ray. When this ray is incident on the surface, let me take it as beam also. When beam is incident on this point, say Q, what we observe? First thing is the ray is or beam is incident from denser to rarer medium, so part of ray is reflected back. Part of ray is reflected back. Part is refracted. This is refraction. This is reflection. This is refraction. This is reflection. This phenomena is called internal reflection. What? Internal reflection. Why is called internal reflection? A part of light is reflected inside, and part of light is refracted. How? As light is traveling from once again denser to rarer, the ray of light is moving away from the normal. It's bending away from the normal. We have to remember this. This is angle of incidence, right? This is angle of incidence phi with respect to normal. Now this will be angle of refraction. What we observe? We observe when angle of incidence in a denser medium increases slowly, angle of refraction also increases. When this angle of incidence increases slowly, angle of refraction also increases gradually with respect to incident angle of incidence. A fine moment is observed when angle of incidence in my notes. I have not mentioned this, okay, to avoid confusion. In your notes, there is no reflected ray. To avoid confusion. Why? Let us discuss, okay? But remember, a part of light is always reflected back there. A part of light is reflected. Okay. Oh, what I am doing? As you increase, listen word by word, as you increase angle of incidence slowly, angle of refraction also increases gradually. A point is reached when your angle of refraction is equal to 90 degree. Your angle of refraction is 90 degree. This angle for which angle of incidence, for which angle of refraction is 90 degree, is called critical critical angle, simply C or IC. Probably I have mentioned C in notes. You put a notes only C and Badi. This is equally what so this is equally right if you what right IC. This is correct. IC is correct. C is also okay, no problem. Here like that. For particular value of incidence, for particular value of angle of incidence, for particular value of angle of incidence, your refracted ray is equal to 90 degree. When the angle of incidence is 90 degree, your refracted ray just grazes. It moves along surface separating these two media. When angle of refraction is 90 degree, this refracted ray, here we have refracted ray. Let me take another way. This is refracted ray. This refracted ray will move along surface separating these two media. It's grazing. It grazes, simply grazes. This angle is called critical angle. This angle is called critical angle. Here too, there is some question. If by chance your angle of incidence increases the critical angle. If angle of incidence is more than critical angle, then there will be no refraction at all. There will be no refraction at all. No part of light is refracted. It is totally reflected back in same medium. It is totally reflected back in same medium. This phenomenon is called total. Here we have used term total. Total internal reflection. Sampurna Antarika Pratifalana. Name of the term is what? Sampurna Antarika Pratifalana. Total internal refraction. TIR. There is no reflection at all. There is no refraction at all. Hope you understood. Let me repeat. Once again, let me repeat. When object is kept, point object is kept at denser medium, first ray which is incident along the normal will move without deviation. First point. As we increase angle of incidence, angle of refraction also increases. Second point. Third point. When for certain value of angle of incidence, your angle of refraction is 90 degree. When angle of refraction is 90 degree, it will move along surface. It grazes the surface separating through media. This side. If your angle of incidence is greater than critical angle, then you observe no refraction at all. The light totally reflects in the same medium. Same medium means denser medium. So this whole thing is called total internal phenomenon. Here we have came across one term called critical angle. Very important for 2 marks. Define critical angle. Critical angle. What is the critical angle? This is important. Critical angle is angle of incidence. What? Critical angle is angle of incidence in where? In denser medium. Critical angle is angle of incidence in denser medium, for which angle of refraction is 90 degree. Let me repeat. Angle of incidence, critical angle is angle of incidence in what? Denser medium, for which your angle of refraction is 90 degree. What is total internal reflection? Define total internal reflection. 1 mark, 2 marks. Then total internal reflection is a phenomenon in which a ray of light reflects totally in the same medium when angle of incidence is greater than critical angle. Or most correct definition is when the ray of light is traveling from denser medium to rarer medium, and if angle of incidence is greater than critical angle, then the ray will reflect in the same medium, in denser medium. This phenomenon is called total internal reflection. This is one more definition we have to do. There is one more question. So called write conditions for total interpretation. ಮತ್ತೊಂದು ಕ್ವಶನ್ ಹೇಳ್ತಾರೆ ರೈಟ್ conditions for total internal reflection. We have two conditions. First condition, the ray of light must travel from denser to rarer, then only you observe this phenomenon. Let me repeat. The ray of light must travel from denser medium to rarer medium. First condition. Second condition, the angle of incidence in denser medium must be greater than critical angle. These two are conditions for TIR. You may have TIR conditions. Next concept. Applications of TIR. TIR total internal reflection ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ? Of course, the phenomenon of total internal reflection is used in a very most used technology called OFC. OFC means optical fiber cable or optical cables, fiber cables. ಎಲ್ಲಿ optical fiber cables ನೋಡಿದ್ದೀರಿ? This total internal reflection, concept of total internal reflection is used mainly in optical fiber cables. OFC ಎಲ್ಲಿ ನೋಡಿದ್ದೀರಿ? ಹೈವೇದಲ್ಲಿ ನೀವು ಹೋಗ್ತಾ ಇರಬೇಕಿದ್ರೆ ಆಚೆ ನೋಡಿ ಒಂದು ಹೊಂಡ ತೆಗೆದು ಒಂದು ಈ ತರ ಒಂದು ಕಲ್ಲನ್ನು ಹಾಕಿ ಆ ಕಲ್ಲು ಮೇಲೆ OFC ಅಂತ ಬಂದಿದ್ದಾರೆ. ಅದು ಒಳಗೆ ಗೌಡ ಹೊಂಡ ಹಾಕಿ ಒಂದು ಪೈಪ್ ಒಳಗೆ ಏನು ಹಾಕೊಂಡು ಹೋಗಿರ್ತಾರೆ? OFC ಕೇಬಲ್ ಹಾಕೊಂಡು ಹೋಗಿರ್ತಾರೆ. ಕರೆಕ್ಟ್? OFC. Our present day communication depends on this. Most of the communication system depends on this OFC also. OFC is dependent. Okay. First application, it is used in OFC, optical cable fiber cable. Optical fiber cable ಹೆಂಗೆ ವರ್ಕ್ ಆಗ್ತದೆ? ಹೇಗೆ ಟೆಕ್ನಾಲಜಿ ಈ ಕಾನ್ಸೆಪ್ಟ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ? ಈಗ OFC has three different layers. Inner layer, okay, some outer layer, and some plastic jacket on it. Some plastic cover on this. Okay, there are actually mainly two layers. The innermost layer is called core. The innermost layer is called core. This layer. The outer layer is called cladding. This layer is called cladding. Refractive index of this core is more than this cladding. Refractive index of this core is more than this cladding. When a ray of light is incident at certain angle, actually ray of light means a light carrying signals, information, audio, video. When ray of light, beam of light is incident on this core, it will undergo multiple internal reflection. Here information is sent in the form of light. Multiple internal reflection. What is the benefit of this OFC? Remember, loss of strength of signal or intensity of light signal is appreciably reduced. It is reduced to most extent. There is no loss of energy. We get at other end we get signal with almost equal strength. There is a very less chance of what? Loss of energy, signal energy. That's why OFCs are considered to send and receive what? Signals or information. There is one more question. You see in your question paper, write any three uses of OFC. Remember, the concept of OLO, this one, total reflection used in OFC. First point I am telling. Second point is where these OFCs are used. Why these OFCs are used? Remember, these OFCs are used in the field of telecommunication. Where? In the field of telecommunication. To send and receive audio and video signals. Let me repeat. Applications of OFC I am telling, right? Don't confuse. Applications of OFC I am telling. Initially, I told you about applications of TIR. TIR is used in OFCs. Concept of TIR is used in OFCs. Now I am telling application of OFC itself. Applications of OFC itself. OFCs are used in telecommunication. OFCs are used in sending and receiving audio and video signals. Even OFCs are used to check internal parts of human body. That kind of operation is called endoscope. They are used in a device called endoscope, where doctors see your internal part of body without actually cutting the human body. Doctors say without actually cutting part, they just insert endoscopic tube and view inside interior parts of our body. These are three major uses of what? These are three major uses of OFCs. To send and receive signals, that's to audio and video signals, telecommunication, and what I said in the medical field, in the endoscopic view. Or sometimes it is used as a decorative lamps. Decorative lamp are used. They are used as decorative lamps. Okay. Now, this is first use of optical photoelectric reflection. Now, second application. Total internal reflection is used in total reflecting prisms. What are total reflecting prisms? There are two types of prisms. One type is used to what? Rotate signal, rotate light by 90 degree. ಒಂದು ಟೈಪ್ ಇದರಲ್ಲಿ ಏನು ಮಾಡ್ತಾರೆ, ಲೈಟ್ ಅನ್ನ ಅಥವಾ ಇಮೇಜ್ ಅನ್ನ ಆಬ್ಜೆಕ್ಟ್ ಅನ್ನ 90 ಡಿಗ್ರಿ ಆಗಿ ಬೆಂಡ್ ಮಾಡ್ಬೋದು. ವಿ ಕ್ಯಾನ್ ಬೆಂಡ್ ray of light into 90 degree. In other kind we can bend the ray of light into 180 degree. ಒಂದು ಕೈಂಡ್ ಅಲ್ಲಿ 90 ಡಿಗ್ರಿ ಬೆಂಡ್ ಮಾಡಬಹುದು, ಮತ್ತೊಂದು ಕೈಂಡ್ ಆಫ್ ಪ್ರಿಸಮ್ ಅಲ್ಲಿ ಏನು ಮಾಡಬಹುದು 180 ಡಿಗ್ರಿ ಬೆಂಡ್ ಮಾಡಬಹುದು ವಿದೌಟ್ ಚೇಂಜಿಂಗ್ ದ ಸೈಜ್ ಆಫ್ ಇಮೇಜ್. ಸೈಜ್ ಆಫ್ ಇಮೇಜ್ ಚೇಂಜ್ ಮಾಡ್ತೇನೆ. Those prisms are called reflecting prisms. Those are called reflecting prisms. For example, see, some object is placed, say AB, a ray of light from this will fall on this prism. Here, somewhere we have A. Okay, one second. Here, is the rest. Okay. Here we have object. Say AB. Okay. This is prism. This is 90 degree. Area of light incident. Okay. Okay. It will move like this. This is point A. You know, this is A. So this will be A. Second, let me consider. Here we get second ray. This will be. Correct. Okay. So what we get? This is A dash, B dash. A dash, B dash. Your object is rotated by 90 degree. What we observe? Your object is rotated by 90 degree. 90 degree rotation. Wow. Okay. Here, one more kind of example. I got this. Once again, see. Okay, first thing, next. Now, this is second. If this is AB, this will be, this is A dash, B dash. Where we rotate the object 180 degree. 180 degree rotation can be. These two prisms, okay. These two prisms are called what? Total reflecting prisms. These prisms are used in Binoculars, you know binocular, right? They are used to binoculars. And one more instrument called periscope. What do you mean periscope? Have you ever heard periscope? Term called periscope, or instrument device called periscope in your high schools? Where it is used? Okay. In submarines, to view, outer view, a long S shape. Okay, there is one instrument called periscope. You can use to see images. I mean, view above your obstacle. If there is some obstacle, you can see using this periscope. You can prepare periscope using these reflecting prisms, even lens, or even mirrors. They are using periscope. The third application is brilliance of diamond. Brilliance of where wrong duster I need now. Okay, somewhere here. So brilliance of diamond. The spectacular what? Shining of diamond is due to this total internal effect. The spectacular shining of diamond is due to this total internal reflection. The critical angle for diamond is around 24.4 degree. I am not wrong. It's yes, 24 point approximately it is 24.4 degree. Very less. When ray of light is incident on any part of diamond, it will undergo multiple reflections, multiple total internal reflections, so that the whole diamond seems to be what? Very bright. And that's called brilliance of diamond. It is what they do. People who collect it from some ore, some place from earth, they will cut into particular angles. They cut the faces into particular angles, so that light once enter will get multiple rotating reflection. It's the skill of those who are people working there. Working means this is technique to cut diamond in particular shape. So these are three major applications of our total internal reflection. Let me repeat: total internal reflection used in total what? Optical fibers. Second, in reflecting prism. Third one, brilliance of diamond. We have three different applications of total internal reflection. And one more question we have to answer: what are the applications of? One application, two applications, three applications of optical fiber cables. Optical fiber cables are used in telecommunication, in sending and receiving audio and video signals, and third one is in decorative lamps. Fourth one is in endoscopic system in medical field as an endoscopic device. Okay, fine. Okay. Before stopping the concept, let me just show one more very important relation. One more very important relation from the point of view, what you call from exam point of view, also from problems point of view. While solving problem, we usually come across this relation. What relation? The relation is the relation between refractive index. See, instead of refractive index, I am writing simply M. Refractive index and critical angle. Relation between refractive index and critical angle. A small derivation. Okay. Just remember the relation. Final answer. Okay. Fine. Let us consider some glass slab or a denser medium where a ray of light, is incident on some point say P on refracting surface AB. We know after refraction, okay, after refraction, if angle of incidence is, if angle of incidence is critical angle, then your refracted ray will travel along surface, making an angle 90 degree. Let me repeat the things once again. Let us consider a beam, a ray of light from denser medium moving into the rarer medium. Let us consider exactly angle of incidence is equal to critical angle. I is equal to IC. I is equal to what? IC. At this condition, your refracted ray will move along surface separating these two media. This is denser, let this be N1. N1 is denser, glass, water, whatever it may be. Let this be N2, which is rarer. To derive the relation, see, refractive index of second medium with respect to first medium. What you are supposed to write? Let me repeat. Refractive index of second medium with respect to first medium is written as N21. Right? N21 is equal to sin I divided by sin R. This is sin I, this is sin R. In this case, this particular case, this is special case. In this case, angle of incidence I is equal to critical angle and angle of refraction R is equal to 90 degree. Automatically, what we get? N21 is equal to sin IC divided by sin 90. Hope you getting this. Very easy, right? I hope you are getting this. Okay. Now, somewhere here. Okay. Now, then N21 will be equal to sin IC, because sin 90 is equal to what? Sin 90 is equal to 1. This is refractive index of rarer medium N2 with respect to denser medium. We are not interested in that. We are interested in refractive index of denser medium with respect to rarer medium. Let me repeat. Our interest is to find refractive index of denser medium with respect to rarer medium, because our object, luminous object, is or ray of light is from denser medium. So this N21 is equal to 1 by N12. Correct? This relation we have derived, this relation we have studied yesterday. Correct? N21 is equal to what? 1 divided by N1. This holds true. This does not. N12 means what? Refractive index of medium 1 with respect to 2. Refractive index of medium 1 with respect to 2. Correct? Refractive index of medium 1 with respect to 2. Or this refractive index of medium 1 is denser medium, medium 2 is rarer medium. Refractive index of denser medium with respect to rarer medium. Hope you understood. Okay. This N21, in place of N21, let me write sin IC. Sin IC is equal to 1 divided by N12, or visible N12 is equal to 1 divided by sine IC. This is very important relation when solving problems. Some of the problems when solving, we are supposed to use this relation. We are supposed to use this relation. See, N12 means N1 divided by N2. N1 divided by N2 visible is equal to 1 divided by sine IC. If refractive index of this denser medium is equal to N, refractive index of denser medium is equal to N, and refractive index of error medium is always 1 below. Refractive index of error medium, here error medium is N. If your error medium is R, then its refractive index is 1. If it is 1, then there is no need to put it as N1, N2. Automatically this will be what? N. So this equation refers to what? In place of N1, let me write N is equal to 1 divided by sine IC. We usually use that equation in that form. What we do? We usually use that equation in that form. Okay? Hope you understand. From tomorrow onwards, let me start refraction through spherical surface, where we enter one more new session where we have to study lenses. There are some equations related to lens, all those things, combination of lens. Okay, then third part and last part, what? Optical instruments. Okay, done. Take care. Thank you.